All right, in 6.4 we talk about vectors, and so we got a lot of just kind of vocabulary definition kind of stuff here that we're going to go over at the beginning. So I'm just going to kind of read through it. So the basics of it are that many physical quantities such as length, area, volume, mass, temperature are completely described by their magnitudes in appropriate units. Such quantities are called scalar quantities. Other physical quantities such as velocity, acceleration, and force are not completely determined until both the magnitude, which is their size, and a direction are supplied. So for example, the movement of the wind is usually described by its speed, which is its magnitude, and its direction. The wind speed and the wind direction together form a vector quantity called a wind velocity. So a vector v is a quantity that has both magnitude and direction. Geometric vectors geometrically, a vector can be represented by a directed line segment with an arrowhead. The direction of the arrow specifies the direction of the vector. The length of the arrow describes its magnitude. The tail of the arrow is the initial point of the vector, and the tip of the arrow is the terminal point. We denote vectors by lowercase boldface type such as A, B, I, J, U, V, and W. Okay, so you can see here in this picture that we have a vector. So let me turn my pen on. I'm going to raise this up a little bit. So let's talk about this vector here. So we can see the vector has an initial point here at P, and it goes to the terminal point, which is here at Q. And there's actually a point there, okay? That arrow is what tells us the direction. That arrow does not mean that this vector right here, vector V as they called it, is going to continue, okay? It just means the direction. So P is our initial point, Q is our terminal point, and the vector's name is V. Now sometimes when we write, we can't write bold letters, right? So we could say that this is V and we draw a little vector over it. So it's called vector V. Alright, so over to the side here, on it says if the initial point of a vector is P and the terminal point is Q, we write V is equal to the length from P to Q. The magnitude of the norm of a vector, V, is equal to segment PQ there, is denoted by, you see it has two bars on the left or right, and with the V inside of it, or it could just have the PQ, and it's the length of the vector V and is a scalar quantity. So let's talk about equivalent vectors. Okay, on the right there it says two vectors having the same length and the same direction are called equivalent vectors. Note that equivalent vectors are regarded as equal even though they may be located in different positions. Alright, so look at the two examples they gave us there. If you look at the first one here, to the left there, you can see that V and W are both the same length. They're going in the same direction, therefore we can say they are equal. But if we look at the second group they give us there, V and U, they have different lengths. Even though they're going in the same direction, they're different lengths, therefore the vectors are not equal. Then it talks about the zero vector. If a vector of length 0 is called a zero vector and is denoted by a bold 0. The zero vector has a zero magnitude and it has arbitrary direction. If you don't have any magnitude, if it's 0, then there's no direction to it. Opposite vectors. If vectors V and A have the same length and opposite direction, then A is called the opposite vector of V, and we write that as A is equal to negative V. Opposite. Change the sign. Same thing. Whoops. For vector addition, tells us we're going to let V and W be any two vectors. We're going to place the vector V so that the terminal point coincides with the terminal point of W. So if we're doing V plus W, you can see here they drew, whoops, you can't see where I'm pointing with my mouse. You can see the first thing they did here is they drew in vector V. And then from that terminal point, because it's addition, from the terminal point, we're going to draw in vector W. To get their solution vector, the resultant vector is what they call it, you're going to go from the initial point of V to the terminal point of W. So start at the initial point of V, go to the terminal point of W, and make sure you put your arrow so you're showing your direction. Okay? So it says, the second little bullet there says the sum V plus W is a resultant vector whose initial point coincides with the initial point of V and whose terminal point coincides with the terminal point of W. Okay, and so what you'll end up with, though the resultant vector is going to be the same, whether we took V plus W or we took W plus V. The order doesn't matter in the addition of vectors. But the big thing here is to be careful because addition and subtraction have different places that they start at. If you're adding vectors, you start at the initial side of the first one and you go to the, initial point of the first one and you go to the terminal point of the second one to find the direction of it. The length would be the same, but the direction will be different if you go the wrong way. So start at the addition. For addition, you start at the initial point of the first one and go to the terminal point of the second one. All right, let's keep going and talk about subtraction now. So for any two vectors, V and W, if we have V minus W, that's equal to V plus the opposite of W. Where where negative W is the opposite of W. We're going to place the vector V so that its initial point coincides with the initial point of W. All right, so when we're subtracting vectors, I'm going to use the little figure on the right here, okay? So we have V minus W. So we're going to draw in our V because it's listed first. Then because we're subtracting, we go back to the initial side of V and we draw in the one that we're subtracting. Now to find your resultant, you're going to, or the difference, which is your resultant vector, you're going to go from the terminal side of W, the second one, and you're going to draw to the terminal side of the first one. Okay? So the difference here is both of them are going to have the same initial side. Draw from the terminal side of the second one to the I keep saying side because of the angles. You're going to draw from the terminal point of the second one to the terminal point of the first one to find your resultant vector. Alright, scalar multiples of vectors. It says let V be a vector and C a scalar, which is a real number. The vector C times V is called the scalar multiple of V. And so, hopefully this makes sense. It says if C is greater than 0, CV is going to have the same direction. If it was positive, it's going to stay positive. If it was negative, it's going to stay negative. So it's going to have the same direction as V, and it's going to have a magnitude of C times V's magnitude. If C is less than 0, then C times V is going to have the opposite direction of V and a magnitude of the absolute value of C times the magnitude of V. And if C is equal to 0, then C times V would equal 0, V, which is just equal to 0 then. All right, so we're ready to look at some examples.